Alright, here we're going to be dealing with some awesome word problems. It's not going to take as long, we're not graphing, I promise, so it'll hopefully go by a lot quicker than those other two examples. Holy yowza. Okay, so in number 3 here, we have the radioactive element americium is used in household smoke detectors, and we denote this, this one here is AM241, and that has a half-life of approximately 432 years. If you guys want to know, the half-life is the length of time for an unstable element to spontaneously decay to 1/2 of its original mass. And one thing, if you guys want to know, your half-life equation, we usually write that as y is equal to 1/2 to the exponent of x. Okay, so just in general, that is your half-life equation there. Okay, and so we're also given that the average smoke detector contains 200 micrograms of AM241. So what they want to know is, what is the transformed exponential function that models the graph showing this radioactive decay? And remember, a decay means that it's decreasing. We can even see that from the wonderful graph here. We're reading it from left to right, and you can see that those values for y are getting smaller, so we have decay there. Okay. Alright, so we have this half-life exponential function. What we're also given here is that our half-life is 432 years. Okay, so what this is going to do is it's going to impact your time. Okay, so what's going to happen is you're going to have y is equal to 1/2. That's going to be to the exponent of x. Divide that by 432 years. So you divide that x value by the half-life, which is 432 years. Okay, then one thing that we also know is that we have 200 micrograms of AM241. So what this is going to do here is that we're going to have y is equal to 200 times 1/2 to the power of x divided by 432. So why did we multiply by 200? Well, this equation here that we had above was for 1 microgram of AM241. So now we have 200 of them, so we have to multiply that whole thing there by 200. Okay, so from there we're not given any more information, so this is from what we're given, what we know. This would be here our exponential function. And one thing we can do is let's verify it. Let's choose a point. Which one looks pretty nice there? Let's say x is, this would be at 300 and 120. So if you want to just put in x is equal to 300, this would be 300 years. So you'd have y is equal to, that'd be 200, times it by 1/2 to the exponent of 300, divide that by 432. If you put all that into your calculator all at once, or you can do it in little steps, quickly put that all into your calculator. And what you should find is that y is approximately equal to, and we should do approximately equal to 123.6. Put that into your calculators. So, and looking at this graph, it's a little bit harder since your y values here are so big. It's really hard to get super exact. So looking at that, it would look like it'd be at 120, but to be 3 off, considering our values there, that's pretty close. So it might mean that we're on the right track. If you wanted to double check, try another point. Okay, so that is just to verify. And here is our exponential function that we determined given all that information. So here, start with your half-life, then go with what you know. So you know that your half-life is 432 years, so you're going to divide that time, x value, by 432. Then we know that we have 200 micrograms of AM241. So this first equation here was for 1 AM241. Now we have 200 AM241. Okay? Then that's all that we're given, that's all that we know. Then once you have that, then verify your points. Okay? Let's move on to number 4. Alright, so in this question here, the real estate board in a city announces that the current average price of a house in the city is $400,000. It predicts that the average prices will double every 15 years. So there's some key information there. I love to highlight or underline just so I can see where some important information is. So it predicts that the average prices will double every 15 years. So now we need to write a transformed exponential function in the standard form to model this situation. So let's look at what we're given. So one key piece of information here is that we know that the average prices of the house, or average price of houses, will double every 15 years. So the keyword here is double. So here our base function, C, is equal to 2. So everything is doubling. Okay? So it's going to be exponentially doubling. That would be great. And we also know that it's every 15 years. So this here is affecting your time period. And maybe we should start off with, let's define x and y. So let's write our let statement. So we'll let x equal time, and that'll be time in years. And we'll let y equal, and we're looking at the price of housing. So we'll do price of housing. And this here is just simply in dollars. Okay. So now let's go back. So we know that the average price of housing doubles every 15 years. So this 15 years is going to be affecting your x value. So when we have our base function c is equal to 2, it's going to look something like y is equal to 2 to the power of x. Let's say that. Then this time here, this every 15 years, it's going to be kind of similar to what we did in 3. So this one here is going to be affecting your x value there. So kind of think about it even as a period or your half-life. So you'll have y is equal to 2 to the power of x over 15. Okay, so actually I would kind of like to see it as every 15 years. So every 15 years it will double. So think about it even if you're not sure, well, you know, how do you know to double, or it should be divided by 15? If you even think about it, so one time period will be 15 years. So if your x was 15, here you would have 2 to the power of 15 over 15, so that's 2 to the 1, so that's doubling, okay? So if you had 30, you'd have 2 to the 4, then that doubles from when it was 2 to the 1, so it goes from 2 to 4. So that's also a kind of a little interesting way to check it, but hopefully that helps to explain why we divided by 15 there, okay? So think about it either as your period, or if you want to think about it as your previous example with your half-life, so it's affecting that time there. And so what we have so far is y is equal to 2 to the power of x divided by 15. And one last piece of information here that we're given is that the average price of housing, and that's currently, so if we're saying currently, that is at time 0, that is currently, so your x is at 0, and so currently it's at $400,000. Okay? So what are we going to do with this then? So what we can do is let's plug this coordinate, or our x and y value, into that equation that we already have. And if it's true, that's totally fine. Or if it's off, we need to adjust it somehow, and we're going to see how nicely this actually works out. Okay, so let's put in our values there. So we have y is at 400,000 is equal to 2 to the power of 0 over 15. That then is equal to 400,000 is equal to 2 to the 0. And then simplify, now we have 400,000 is equal to 1. So that obviously there isn't true. So then you can ask yourself, well, what do I have to do to our equation that we had here to make this true? How do we get 400,000 to be either equal to 1, or how do we get 1 equal to 400,000? So what we're going to do here is, this is going to say, well, what happens if we multiplied our right side by 400,000? That would sure give us 400,000 on each side, now wouldn't it? So that's going to give you that clue there. So we're going to have this A value of $400,000, or just 400,000. So what our equation there equals, so we have y is equal to 400,000 times that by 2 to the power of x over 15. Okay? So from there, you can double check, put those coordinates back in there, see if you still get that exact same answer. But from there, we're not given any more information, so from there, we're good to go. And that is our equation, or exponential function, representing the average pricing of housing. Okay? So you guys can get started on your homework, and If you guys have any questions, let me know. But other than that, have a great weekend. Thanks, ladies.